right, in this third video, we're looking at the examples that were you try in those notes for 3 variable systems. And that first one, or well, technically number 4, you needed to get that 3 variable system down to a 2 variable system. And to do that, I chose to eliminate the z's and get one equation that was x and y, and then get another equation that's x and y. That is your choice. You could do that to eliminate any of the variables. You could also do substitution, but our goal is to create a 2 variable system. So the 2 variable system that I got would have both negative 3x minus 2y equals negative 11 and negative 3x minus 2y equals negative 13. What sometimes makes learning these concepts difficult is that there are a variety of ways that you could approach the problem. Some people may have chosen to eliminate the x's. Some people may have chosen to eliminate the y's. Or some people just may have done substitution altogether and they substituted in an expression for x and got a 2 variable system with y's and z's. Regardless, however you do it, you're going to get down to a 2 variable system that when you solve, your variables disappear and you get to an equation that is not true. I got down to the equation 0 equals negative 2. Well, this is not a true statement, therefore there is no solution to this system. For number 5, as you were working this one out, you would still need to get down to a 2 variable system. I chose to eliminate z's again, so I put the first and second equation together, multiplied the first one by 2, which allowed me to eliminate the z's, the negative 4z and the positive 4z. It gave me an equation of 4x plus 6y equals 4. Now that's one 2 variable equation with x's and y's, but we already had a 2 variables equation with x and y, so if I put those together as my 2 variable system, you should see that they are the same equation, which might automatically tell you it's going to be infinitely many solutions. But either way, I would maybe eliminate by multiplying one equation by negative 1. That led me to the x's canceling out. They added to 0, the y's add to 0, negative 4 plus 4 is 0, so 0 does equal 0, which means we do have infinitely many solutions. Because there are infinitely many solutions, we need to express our answer in terms of z. That would mean I need an equation with only x's and z's and another equation with only y's and z's. To do that, I put the second equation together and solved for z. Sorry, I solved for x. So x is equal to some expression about z, which is negative 2z plus 2. Then we needed another equation that was only y and z. Now this one I needed to do some work to get to. So I put the first and second equation together, multiplied by negative 2 to eliminate my x's, and that resulted in an equation that was only y and z. If I solved for y, I can express y in terms of z. Therefore, my solution would look like x as negative 2z plus 2, y as 4/3 z minus 2/3, and z is just z. Now we do sometimes have directions that state for us to do it a different way. So if the direction stated to let z equal t, then we would just change those z's to t and our solution would look like this. X is negative 2t plus 2, y is 4/3 t minus 2/3, and z is just t. All right, so hopefully those 2 examples gave you a little bit more practice. If you need more practice, there is still more posted and you can check the answer key for that. We're going to move on in the last video looking at application questions for 3 variable systems.